Touch the side of your neck, 2 fingers, just under the jaw. Find the pulse. That rhythmic throb is blood moving through your carotid artery, the main supply line to your brain. Now notice where it sits. Not buried deep behind bone, not shielded by muscle. Right there, a centimeter under the skin, pulsing against your fingertips. The real question isn't how the blood gets to your brain. It's why your body put a pressure-activated off switch on the main cable and left it completely unguarded. That off switch has a name, a history, and a 450-million-year-old job description. And it starts with the thing it was actually built to do. That spot you just pressed is called the carotid sinus. It's a slight widening at the base of the internal carotid artery, sitting about 2.5 centimeters below the angle of your jaw, and it's lined with pressure-sensitive nerve endings, baroreceptors, wired through a nerve in the throat directly to your brainstem. Its job is simple: sample arterial blood pressure beat by beat, in real time. When pressure climbs, the brainstem slows the heart and opens up the blood vessels. When pressure drops, the opposite. Speed up, tighten, compensate. This loop is called the baroreflex, and it's the fastest blood pressure regulation system your body has. It runs continuously, without your input, without your awareness. Every heartbeat, this thumbnail-sized patch of artery wall is reading you like a gauge. In 1933, a physician named Soma Weiss pressed on that patch deliberately in 15 patients who seemed unusually sensitive to neck pressure. He held the pressure for 5 to 10 seconds and recorded what happened. In some, the heart slowed dramatically. In others, blood pressure collapsed. In a few, the heart stopped beating entirely for over 3 seconds. 3 seconds. No heartbeat, no blood reaching the brain from pressing a spot on the neck. Weiss drew a line at that 3-second mark. If the heart pauses that long during carotid pressure, the response is clinically significant. That threshold, set somewhat arbitrarily from just 15 patients, is still the diagnostic standard used worldwide today. He also noticed a pattern in who kept showing up: clergymen, men in high-starched collars, leaning over pulpits, fainting mid-sermon in front of the entire congregation. The medical literature started calling it minister's disease. So the picture seems clean. The carotid sinus is a pressure sensor. Modern clothing and neck contact can accidentally compress it. The brainstem reads the pressure as a spike in blood pressure and fires a correction. Heart rate drops, vessels dilate, pressure plummets. In an upright human, that means the brain loses its blood supply. You faint. A system designed to protect you becomes the thing that drops you. That explanation is satisfying. It makes sense. And it's only about a third of the story. Here's a question the collar compression story doesn't answer. Why does the reflex exist in the first place? The baroreflex regulates blood pressure. Fine. But the vasovagal response goes beyond regulation. It doesn't just correct, it overcorrects. It crashes blood pressure, crashes heart rate, and in humans, crashes consciousness. That's not a fine-tuning tool. That's an emergency shutdown. Pressure sensors don't normally come with a self-destruct option. So what is this system actually for? In 2023, neuroscientist Jonathan Lovelace found the switch. Using single-cell genetic sequencing and a tissue-clearing technique that makes brain tissue nearly transparent, Lovelace mapped a specific population of nerve cells running from the heart's ventricle wall to a target deep in the brainstem. These neurons had a distinct genetic signature, and they formed a circuit completely separate from the normal baroreflex. Then he activated them with light. Picture a lab mouse running freely in a glass-walled chamber. A blue light pulses through a fiber optic cable threaded into its skull. Mid-stride, the mouse freezes. Pupils blow wide. It crumples sideways, eyes open, limbs splayed, motionless. 7 seconds later, it scrambles back up and keeps running as if nothing happened. The light triggered the full package: blood pressure collapse, heart rate collapse, suppressed breathing, and when Lovelace destroyed those specific neurons, the reflex vanished. Gone. But the normal baroreflex, the one that adjusts your pressure when you stand up, kept working perfectly. 2 separate systems. The system that fine-tunes your blood pressure moment to moment, one circuit. The system that can knock you unconscious, a different circuit with its own neurons, its own wiring, its own brainstem target. Your body didn't build one pressure tool, it built 2. One for maintenance, one for emergencies. The strangest part is still coming, because if the emergency system isn't about correcting blood pressure, what emergency was it built for? The answer is bleeding. Massive blood loss. When an ancestor lost roughly a third of its blood volume, a predator's bite, a deep fall, a fight. The vasovagal reflex fired. Heart rate dropped, blood pressure crashed, and the body either went flat or was forced flat by the collapse itself. That brought the brain back down to heart level and restored some blood flow. In 2009, scientist Rolf Diehl tested what happens to the blood itself during one of these events. He used a sealed chamber around the lower body that pulls blood downward, simulating the kind of blood volume drop the brain would interpret as major bleeding. 21 subjects went in. 16 of them developed a vasovagal response. In those 16, plasma concentrations of two key clotting proteins, von Willebrand factor and factor VIII, spiked significantly. The 5 subjects who didn't develop the reflex showed no change. Fainting activated clotting. Your body doesn't just drop you. It drops you and starts plugging the hole it assumes you have. The reflex isn't a glitch. It's a package. Pressure crash, heart rate crash, consciousness crash, clotting boost, all bundled together. An emergency bleed kit, triggered automatically, running on a circuit older than the evolution of limbs. So the system isn't broken. The system is extremely good at what it was designed to do. The problem is what it was designed for. The assumption most people carry is that fainting is a defect, a weakness, something your body does wrong. The data says otherwise. The vasovagal reflex is not a disease. It's a conserved defense mechanism present across every class of vertebrate: fish, amphibians, reptiles, birds, and mammals. It has persisted for roughly 450 million years. It appears in sharks as a bleeding-triggered heart rate drop, in reptiles as the freeze and drop response, in mammals as the full vasovagal response. If it were harmful to survival, natural selection would have dismantled it hundreds of millions of years ago. It persisted because it works, in the world it was designed for. The reflex isn't broken. The environment is. For 450 million years, this system fired in response to genuine bleeding, genuine predation, genuine cardiovascular crisis, situations where crashing blood pressure and boosting clot formation was the difference between surviving and bleeding out. The world it was built for didn't have neckties, didn't have tight collars, didn't have seatbelt straps across the throat. Nothing in that world routinely compressed the neck. Pressure on that spot was rare and almost always real. A predator's jaw, a constricting threat, the pressure wave of genuinely rising blood pressure. There's a second mismatch, and it's the reason humans faint while other animals running the same reflex don't. When the vasovagal response fires in a 4-legged animal, the brain stays roughly level with the heart. Blood pressure drops, but the brain still gets enough flow. Consciousness holds. In an upright human, the brain sits about 30 centimeters above the heart. The same blood pressure drop that a dog would barely notice drains blood from your skull. You go dark. The system has no way to tell a shirt collar from a predator's jaw, a blood draw from a stab wound, a tilt table test from falling off a cliff. So it fires the same full emergency package. Every time. The enemy was never the reflex. The enemy is the model you've been carrying of your own body. The belief that consciousness is sturdy, that you are in charge, that passing out means something went wrong. In reality, a 2.5 centimeter patch of artery wall has override authority over your awareness. The system didn't ask for your consent. It doesn't need it. It was running before your species existed, before consciousness itself existed. That spot on your neck, the one you felt at the start, it's not just a pulse point. It's a direct line to a circuit that predates everything you think of as you. So next time you feel that pulse under your fingers, just below the jaw, soft and steady, know what you're actually touching. Not a weakness, not a flaw, not a glitch in the wiring. A 450 million-year-old emergency protocol, still running, still armed, still convinced that the most important thing it can do for you is shut you down before you bleed out. It can't read the collar around your neck. It can't check whether the blood it sees on a screen is yours. It doesn't know what a necktie is. All it knows is the pattern it was built to answer: pressure, blood loss, threat. And it will answer it the same way it has for every vertebrate that ever lived. About 40% of people will faint at least once in their lives. If you're one of them, you didn't malfunction. You activated. Your body would rather knock you unconscious than let you bleed to death. It just can't tell the difference anymore.